Hello everyone, I am Vijay Katta and in today's lecture we will study network layer design issues. So I am going to cover the following topics, that is a network layer design issue, forwarding table and routing algorithm concept, datagram switching and virtual circuit switching, principle of optimality and sync tree. So we will start with the network layer. As you know, network layer is a third layer. It is called as the L3 layer in OSI model. Basically, this layer is responsible for delivering the packet from the source machine to the destination through multiple hoops. Hoops means an intermediate devices called as the routers. So on the sending side, it encapsulates the data received from the transport layer into the packet that is called as the datagram. And on receiving side, network layer, it decapsulate the packet and transfer the data portion to the transport layer. Next, network layer is basically responsible for the routing. It performs a routing, that is from a transmission of packet from one hoop to the another hoop. So the major concern is the IP datagram. So IP internet protocol is present in the network layer. It performs a packet delivery service that is called as a host to host, and all packets are encapsulated into the data link layer protocol that is called as the frame, and then it is forwarded. Now next is the design issues of the network layer. Now I discuss this concept with respect to the OSI model. So basically, first and most important aspects of network layer is perform store and forward packet switching technology. So in the store and forward mechanism, we need two things. First one is called as a forwarding table. Second one, we need a routing algorithm. Now here the word stored, it means whenever packet is arrived on the router, this packet is stored in the primary memory. Then according to the forwarding table and routing algorithm, decision has been taken and packet has been forwarded. That's why it is called as a host to host routing. Next service is a service, it provides the services to the transport layer. Third issue is implementation of connectionless services and implementation of connection oriented services. And next is addressing, we already studied this addressing concepts. So in the stored and forward packet switching technology, this A, B, C, D, E, F represents the intermediate node called as the routers. Now this collection of routers are called as a small I internet. So this complete network portion is called as a small I internet. Now capital I internet is a service which is provided by this small I internet. Now in fact this F is also considered as the router. Now suppose host H1 want to transfer packets to host H2, then first thing, that packet will be received on input line of this router. Now with the help of forwarding table, router A will decide which is the best outgoing line, and now suppose this is the best outgoing line. So forwarding is a mechanism through which we take a packet from input line, selects a best output line and transfer the packet on that line. Now, similar pattern, same decision will be performed by router C and other routers, and then finally packet will transfer to host H2 or H2 machine. So, in the store and forward packet mechanism, or called as a routing mechanism, there are two key concepts. One is called as a forwarding and another is called as the routing. Forwarding is a move packets from router's input to appropriate router's output line. As I mentioned, when packet received on the input line, this router take appropriate line, whether this path is the best one or this one, So with the help of the table, it is decided, and then we transfer the packet on next outgoing line. So selection of outgoing line on a particular router is called as a forwarding. And routing, it determines a route taken by packet from source to destination, and for this purpose we need a routing algorithm, or we implement it through the programming. So path taken, for example, the path taken by this packet is from A, C, E, F. So this is a routing path through which a packet has been transferred from source H1 to machine H2. This is called as the routing. So again, with through this diagram, routing algorithm determines end-end path through networks, and forwarding table determines. This is one example of forwarding table on which our routing algorithms work. Local forwarding path, that is from input line to the appropriate output line. Now, next one is a service provided to transport layer. In OSI model, each layer provided services to upper layer. Now, major concern of network layer is to provide a packet forwarding. Network layer has an addressing scheme. Now, it is implemented connection-less services. Now, how to how to provide a services to transport layer. So, the services should be independent of the router technology. So, transport layer is free from underlying router technology. So transport layer has nothing to do with the router technology. The only concern of transport layer is end-to-end, that is a process-to-process delivery. So what network layer is doing, it has nothing to do with the transport layer. Transport layer should be shielded from the number, type, or topology of the routers. Transport layer is only interested from process to process delivery, not host to host delivery. This is a responsibility of network layer. Now, in fact, transport layer is free from the network addressing scheme. That's why at transport layer, we implement the port addressing scheme. Now, there are two types of services that is called in the OSI model. By the way, in TCP IP model, network layer is a connection less only. But we are discussing network layer design issue with respect to OSI model. So we provide connection-oriented services and connection-less services. So Datagram network provide connection-less services, while virtual circuit switching is called as a connection-oriented services. Now third one is also message switching, but here we implement only datagram switching and virtual circuit switching. So implementation of the connectionless services. Now this is called as a datagram switching, called as a datagram network. So I mentioned here the network is called as the datagram network. It means each packet is forwarded or routed separately. Suppose I have to transfer 3 or 4 packets from this machine H1 to H2, then each router will take a decision for each packet independently, and it might be possible these all packets take a different path according to the current router or internet situation. So forwarding table is, again, it may be a static or it may be a dynamic. We will discuss in the routing algorithms. Now, it is highly impossible to keep a record of 2 power 32, which is approximately 4 billion IP addresses are available there. So rather than keeping a record of 4 billion IP addresses, we just put a list of range of IP addresses. Means for a particular range, I will select output line 3. From this range to this one, packet will forward it to the output line 2. Similar pattern from this range to this range, packet will again forward to output line 1. This information is maintained in the forwarding table. It means in the datagram switching, each packet has been routed separately. Now, Next, an important aspect is the implementation of connection-oriented services. Sometimes connection-oriented services are also called as the MPLS, that is stands for multi-protocol level switching. Now, in connection-oriented one, a path from source router all the way to the destination router must be established before any data packet can be transferred. It means when first packet arrived on a particular router will select a optimal path that is called as a best path. Then to that best path, it will assign one unique sequence number that is called the VC number, virtual circuit number. Then all packets will transfer with the help of that VC number. That is called as a virtual circuit network. Now, I have discussed this thing in this particular diagram. So, this is in a virtual circuit forwarding table. Rather than keeping the IP address details, what we will do, suppose this is one machine, want to transfer data to this machine one, and this is in port number 1 for this router, this is a port number 2 for this router, and this is a outgoing port for uh, this particular router. This is number 1, 2, 3. Now suppose a packet comes, then for this communication, means from this machine to this one, we assign a unique number that is called the incoming VC number. So this is on port number 1. Communication has assigned a sequence called as a 12, and whenever data come with this VC number, it will be forwarded to interface number 3 along with VC number 22. So it means for one communication, we assign incoming VC number and outgoing VC number, and all packets will forwarded on the same path. So this is a difference between virtual circuit one. Now I have compared datagram switching along with the virtual circuit switching techniques. So first one, that is a circuit setup. So in datagram network, circuit setup does not require each packet routed independently, while in virtual circuit network, path setup is required. Now addressing, each packet contains full source and destination address, means each packet contains source IP address and destination IP address. This is a 32-bit IP address in IPv4. While in virtual circuit, only first packet contains the IP address, remaining all packets contain a short VC number as discussed in the previous slide. Now, what are the state information maintained? Router do not hold state information about connection. As packet is transferred from incoming line to outgoing line, then the record has been deleted. No state information has been maintained. But in the virtual circuit, each router maintains incoming VC number label and outgoing VC number label in the table. So routing, each packet is independently routed. Now, in virtual circuit switching, route choose when VC is set up, all packets follow it. Effect of routing failure. It is a very small impact. Either a packet will lost, either a single packet will be lost if router fails. But it performs a higher impact on virtual circuit switching, because in virtual circuit switching, we maintain a state information. If router will fail, then complete state information will be lost. So next parameter is the quality of service. It's very difficult. We cannot say whether data will be transferred or not because it is a connection less services. Now here it is quality of service has been maintained because it is a connection oriented one. Now congestion control in datagram switching, congestion control is very difficult, while in virtual circuit switching it is easy because we can, if congestion occurred on a particular router, we will delete virtual circuit label so that next packet will be stopped and routing will not be performed, so that we can remove the congestion. But in datagram network, it is very difficult. Now, I summarize my lecture. So, duties of the network layer are internetworking, addressing, routing, packetization, and fragmentation. So next one is a basic routing algorithm. So main function of network layer is to perform the routing. So algorithm that choose the route and the data structure that they use are a major area of network layer design. So major concern of the network layer is to optimize the routing algorithm and choose the optimal path. Now routing, there are two types of routing basically called as a datagram routing and session routing, that is a VPN route. Now in my current lecture and all upcoming lectures, I will focus only on the datagram routing one. So each these are the desirable properties of the routing algorithm. So routing algorithms, one routing algorithm that is called the shortest path algorithm. Another one is a Bellman, another one is a distance vector, and some other algorithms are there. So what are the desirable properties? So first property is called as it should be always correctness. Algorithm should be simple. It should be a robust. Once a major network comes on the air, it may be expected to run continuously. Means that algorithm should run continuously for the years without system-wide failure. That is called as the robust. Next property is the stability. See, there exists a routing algorithm that never converts to the fixed set of paths. So no matter how long they are. Means always it should not be converged to the fixed path. Algorithm reaches equilibrium and stay there. And next one is called as the fairness and efficiency of it. Now most important topic is a optimality principle. Most of the time university asks this question, what do you mean by the optimality principle? Now this is a one single statement given by Bellman in 1957, and the statement is, it stated that if router J is on the optimal path from router I to router K. It means J lies between I and K, and we know the best path between I to K. Then the optimal path from J to K also fall on the same route. It means out of so many lines from I to K, we have chosen a best optimal line, and J is available on that best optimal line. It means the path from J to K also optimal. And this is a simple statement given in the optimality principle. Now, optimality principle can be represented with the help of tree, and it is called as a sync tree. Now, I have discussed the sync tree here. Now, in diagram A, we have represented these are the nodes. They are connected by the different path. So, cycle is a present here. Now, we will remove the cyclic path. We will uh, we will convert into the tree. So graph is converted into the tree. Now it might be possible some alternate diagram also possible. So we cannot say sync tree is a unique one. Now there is no loop here. So sync tree, note that sync tree is not necessarily unique. Other trees with the same path length maybe exist. So you can find the alternate diagram also here in which there is a no loop. Since sync tree is indeed a tree, it does not contain any loop. So each packet will be delivered within a finite and bounded number of hops. The basic concept behind development of sync tree is to find the finite path so that we can define TTL time or maximum hope limit. If we allow all the possible paths to be chosen, the tree become more general structure called as a DAG, that is a directed acyclic graph. Now in my next lecture, we will complete the routing algorithms. Okay, thank you.